Let's get started with the problems on maximum and minimum. So here's the very first one. Maximum product of numbers. The question is, the sum of two positive numbers is 12. If the product of one number by the cube of the other is to be a maximum, find the numbers. So all these problems we should define our variables. So we say let the numbers be x and y. Now once you have the numbers, you should also get the relation. If that is the case, then what is the relation? Say sum of two positive numbers is 12, right? So we also know that both x and y are actually greater than 0, correct? Now, sum of the numbers is 12, that means x plus y equals to 12. Now let's move on. If the product of one number by the cube of the other, that means what we are saying is x times y cube. This is what we are interested in. If the product of one number by cube of the other number is to be maximized, find the numbers. So whenever we say product of this, we have to define another variable, and that is let the product be equals to this. Do you get my point? Now we have an equation which is in two variables. That is difficult to solve. Well, there are a couple of ways we could do it. So one way to do it is you write y in terms of x. The other way is you can actually differentiate this equation with x, this also. You'll know what dy dx is and substitute the value. So there are two ways to go about at this stage. So I'll actually adopt both methods and show you with this example how actually both ways work, right? So from this equation, you know one thing, that y is 12 minus x, correct? So y is 12 minus x. Let me write y equals to 12 minus x. So I'll substitute this value here and get one equation which is in terms of one variable, which is x, right? So I say product in terms of my variable x now, right? Now once I have this, I can differentiate this with respect to x, and so we get p dash x equals to all this, and I'll use the product rule, which is product of this times this. So 12 minus x whole cube plus x times product of this. Product of this is 3, and let me write x now, and 12 minus x square, and derivative of minus x will be minus 1. Now to find maximum or minimum, this could be 0, right? Only then we get a critical number. And once we equate this to 0, then we can find what critical number is. So we have 0 equals to all this. So let me factor out a few things that I did in a factored form, since always factored form is easy to help us out in solving such questions, right? So 12 minus x is common factor here. So we will do this. Take this out and you get 1 here. You get 12 minus x whole cube here. So you get 12 minus x whole cube divided by this is a square, and you're left with minus 3x in this case, correct? So that is your equation. And now to solve this equation, we get here we get x equals to 12. That is one option. If x is 12, the other number is 0, which doesn't really help us out. So let's solve this portion. This could be 0, right? So that means 12 minus x whole square minus 3x. So let's solve for this. So let me write down this equation on the right side and then further solve it. So what I get here is, let me write 12 minus x times, we'll expand this. So this square will be 144 minus 2 times ab, which is minus 24x, and this is x square plus x square minus 3x, and we want to equate this to 0. This is what we're trying to figure out. So we get 12 minus x times, so 144, and this is minus 27 minus 27x plus x square equals to 0. So that is what we get. Now we need to factor this. So we are looking for two numbers whose product is 144 and whose sum is minus 27. So the numbers could be, let's work it out. 12 times 12 is 144. So let's factor this. So we get 144. It could be 12 times 12, and this could be 4 times 3 and 4 times 3. So 16 and 9 could work, correct? So you have 4 times 4 is 16, and 16 plus 9 is 27. So 16 and 9 can work, right? So we will write this as 12 minus x times. Now, so I'm writing it like x, both should be negative. 16 and x minus 9 equals to 0. So that gives us two numbers, and the two numbers are 16, or so these are the options, right? So this is equal to 0 if we have x equals to 16, or we have x equals to 12, or we have x equals to 9, right? Now as you can clearly see that x cannot be 16 or 12, right? Since we are two positive numbers, the only number which could give you, because we need both positive, right, is actually 9, right? So that could be a possible answer here. So x equals to 9 is a possible answer here, right? The others are not possible, because if I write one number as 12, the other number becomes 0 or negative, correct? So x equals to 9 is the only possible answer from this set of values. Now, even from the values that x plus y equals to 12, we know what is the domain of x, correct? So let's write down that domain here itself. So from here, what we can say is that x is actually greater than or equals to 0, but is less than or equals to 12. So that's the domain. So we cannot take 16 as our value, all right? So x equals to 9 is the critical value. So if you find the value of the function at, so function's product, right? So let's calculate product at these values, that is 9, and the boundary conditions at 0 and at 12. So if I write product as 12 here, I get 0. If I write 0, I get 0. So in these two cases, we get 0. Now here if I write 9 here, then what do I get? So I get 9 times 12 minus 9 cubed, right? Which is, we can use the calculator. 9 times is 3 cubes. So 9 times 3 cubes, 27. So we get 9 times 27 equals to 243. So we get product of 243, correct? And therefore, we can say that our answer here is that the numbers are, we know x is, so x is 9. If x is 9, what is the value of y? Y will be 12 minus 9, right? So we can write down our answer, that is x equals to 9 and y equals to 12 minus 9, which is 3, correct? The numbers are, so the numbers are 3 and 9, correct? So that is our answer.